This is Learning Python Data Analysis, published by Pack Publishing. I'm Ben Hoff, getting insights from tweets. In this section, we're going to take a look at grouping by dimension, classification of data types, trend analysis, deriving new metrics, and correlation analysis. So let's go ahead and get started. We're going to work on categorizing or classifying our tweeters. Whereas before we were labeling our data and then feeding it into an algorithm to figure out how to classify the data based on our labels, this time we're going to feed algorithms raw, unlabeled data and have them group the data for us automatically. This trick is known as unsupervised learning. We're going to start categorizing our users in Jupyter Notebook. Now I'm going to do a little bit of some fast setup here to get our users. And we'll just import matplotlib, import numpy-pandas, and get access to our Twitter table and our users. And if we take a look here at some of our user information, what we can see is we've got a couple of measures that will be very useful in determining sort of if a user is broadly influential or not. And two of these columns that we're really interested in is our followers count and our listed count. So if you're not familiar with Twitter, right, a listed count is something Twitter users can put other users in lists, and a listed count is how many lists you are a member of. So between these two metrics, we've got a couple of decent measures of influence. So let's go ahead and take a look at our data. And we'll just use matplotlib to do this, and we'll use a scatter plot, and we'll go ahead and get our listed count, and we'll go ahead and look at our followers count. Now if we look at this data, what we can see is we've got a lot of variability, right? So we've got this guy up here in the very far right hand corner, and we've got a couple of people in between, and then we've got a lot in this group. So we're going to need to kind of bring all of this stuff together and make this a little more congruent. And one way to do that is to use a nonlinear scaling method. A common nonlinear scaling method is numpy. So let's go ahead and do that. So what we'll do is for our two columns that we're interested in, we'll go ahead and make a new column, and we'll call this our log followers, right? And all this is going to be is from the followers count, we're going to use the apply method to put the log method on there. And then we'll do the same thing for our listed count. Trying to spell correctly, we'll do a listed count apply our numpy.log. And now if we go ahead and plot this data, so let's go ahead and plot a scatter plot of our log followers and our log listed. What we can see is this is a lot better and easier to see, right? And we've got a clear trend here towards the upper right. So that helps bring our data much easier for our algorithms to classify because there are clear patterns. Now, one thing that we need to account for is if we go ahead and look at the log of a zero number, for example, we will get a negative infinity value. So we've got negative infinities in there somewhere, and we need to go ahead and get rid of those. The easiest way to do this is to go ahead and use the replace method, and we're looking for our numpy negative infinities, and we'll place those with 0. And we'll do this for both of our data members. And one thing that I always forget when I'm doing this is to go ahead and do this in place so it'll actually take effect in our data member that we're interested in. Awesome, so now we're ready to classify our users. Now we're going to use k-means clustering, which according to Wikipedia partitions a number of observations into a number of clusters. So in our case, we're going to partition our users into two categories, either broadly influential or not broadly influential. So let's go ahead and split off the two columns that we're interested in. Go ahead and make a data member called fitme, and this is going to take in from our users, our followers, and our listed count here. And one of the first things that we want to do whenever we're using k-means 2 is to actually do what's known as a whitening linear transformation. And what a whitening linear transformation does for our input is go ahead and remove the correlation between our two data members. And basically what this does is it makes the important bits of the information really important, and it kind of takes out the correlation, because obviously as you have, in this case, more followers, you're going to have more listed. So this is a programmatic way to kind of remove some of those effects. And one thing that I forgot to do is we actually need to go ahead and get access to our algorithm. So we're going to import from SciPy, which is where this is at. We'll go ahead and import the cluster module. And then we'll go ahead and do the whitening that I was just talking about. And in the cluster module, there is the vector quantization package. And that has our whiten function. And we'll go ahead and pass in data members that we're interested in. And then once we've actually done the whitening, we can go ahead and do our classification. So we're going to start with using the k-means2 method, and I'll explain why in a little bit, but the k-means2 is going to return us both our centroids and our labels, and I'll show you what these do in a second. But again, cluster, vector quantization, and k-means2. Now we need to pass in our whitens, and we also need to pass in how many clusters we want to do. So in this case, we're going to go ahead and do 2 clusters. And lastly, now that we've got all of that, let's just go ahead and plot this all up. So we're going to use a scatter plot, stick with the plan, and we'll pass in our log followers and our log listed. And then I told you, so if we, the centroids are the centers about which our algorithm is going to classify, which I'll kind of show you, explain that in a second. And then our labels is actually which class it's part of. So if we go ahead and pass in our labels for our colors right here, it'll go ahead and show us how it split up our data. Perfect. So we can see we've got a binary classification of our most broadly influential and our not so broadly influential users down here in the bottom, and you can see these are split up by color. And what this done is we've got 2 centroids, and according to our algorithm, right, these data members that are colored are grouped kind of closer to our 2 centroid values, and we'll actually use that in a second. So the nice thing about this algorithm is that we can throw in multiple dimensions worth of data. We can't, we can throw in more than just 2. So let's go ahead and do that. So we'll add in our friends. So we've got our followers, we've got our listed count, and now we'll go ahead and add in our friends, because the more friends we have, the more likely influential we are. So do the same thing, we'll go ahead and take the log of our friends, and then we'll replace those negative infinity values. And once we've done that, we'll go ahead and get what I'm calling like a fit me extended, but we want to get all 3 of our data members here. So we've got our logs, our followers, our friends, and our listed count, the log of all those values. And then again, same. We're going to go ahead and do the whitening transformation. And that is the whiten method in the vector quantization package in the SciPy cluster module. And we'll go ahead and pass in our data member, which is fitme extended in this case. And then once we have our whitened linear transformation, and if you're interested in what this actually does, this Wikipedia link has a pretty good description of how it works. You kind of have to understand linear algebra a little bit, but with that you can kind of understand what that transformation is actually doing for you. But again, we are interested in getting both our centroids and our labels using the vector quantization k-means2 function, and we'll pass in our whitened and the number of classes we want. Go ahead and let that run. So now that we've got that, let's go ahead and plot our data in 4D, which is 3 dimensions, and a 4th dimension is the color dimension. So I'm just going to copy paste this code out. It's not super fancy. But one of the things that we need to do in order to do 3D plotting is we need to actually import this axis 3D from matplotlib toolkits.matplotlib 3D. Otherwise this won't work. We'll go ahead and create a figure. Excuse me, and then we'll get our default axis, and we'll go ahead and tell it that we want a three-dimensional projection. And then one of the things that I need to make sure is that we've actually followed the convention here. So we've got followers, friends listed. Okay, that looks right. Followers, friends listed. Perfect. And then we can just pass in our labels and go ahead and plot this. Cool, so now you can see the effects. We've got our three axes, our followers, friends, and our list. And again, we see a broad trend here. The farther you get up into this upper right-hand quadrant here, the more broadly influential you are, which is pretty cool. And we've actually got that classification decision based on 3 different dimensions. So 2 dimensions, or 2 classifications, or 2 classes is all fine and dandy, but what if we want more clustering? Well, we can actually look at the distortion as given off by our algorithm and try to figure out how many clusters we want to best define our data. So if we're not just looking at a binary classification, but say we wanted to dig into this a little bit more and figure out how many clusters best defines our data, we can actually look at the distortion. Now, in order to do that, instead of using k-means 2, we'll go ahead and use its predecessor, the illustrious k-means method. And what we're going to do is actually plot out our distortion as a function of the number of clusters. So we need to go ahead and get clusters, and we're going to do a list comprehension to get this. And then, again, very simple vector quantization. And we'll do k-means, and we'll need to pass in our whitened transformation. And then for the number of clusters, we're just going to put I, and then we'll do for I in range. And we'll pick some pretty large numbers. So let's go from 1 to 30, for example. And we'll go ahead and let that run. And I'll talk a little bit about the return type. So the return type for k-means is, again, still our centroid. But now, instead of getting our labels, what we've actually got is our distortion, a distortion value, which is what we're trying to minimize, right? Less distortion means that we are better fitted to our data. And once that's all done, we'll go ahead and plot this up, which I'll just go ahead and get ready. So we want to distortion. I'm just going to put distort because I can't spell. So distort for our centroid, distort in clusters. So taking a look at this plot, right, we've got our distortion on this left-hand side, and then we've got the number of clusters on the X side. And what we're looking for is the point where adding clusters does not significantly decrease our distortion. So what we'd really like to see is this be a little bit more strict, right? I'll drop down, and what we're looking for is what's known as the elbow. So in the perfect world, this would drop straight down, form almost sharp 90-degree elbow bend. And that's the information we're looking in, or interested in looking at, because we don't get additional distortion loss really for more clusters, which just adds complexity. Now, this data is already pretty complex and large, so we don't see as significant a drop as we'd like normally. But you can start to see how, for a number of clusters, you start to get a little better fit of your model. So for our case, we could probably run this out and see where this kind of tails off, but let's go ahead, because you can't really see much more than 7 or 8 clusters. So we'll just kind of grab from right there. And we'll go ahead and get our centroid and labels is equal to cluster dot vector quantization, k-means 2, and we'll pass in our whiten, and then we said, what, 8? 8 sounds like a good number. And then if we go ahead and plot this again, and I'm just going to cheat and steal all this information. And one thing that I'm going to do that's a little bit different here, so let's go ahead and change our matplotlib to be notebook so that we can kind of dynamically interact with this. One thing I forgot, once we do that, Need to make sure that we actually show our figure, otherwise we won't get any information. Awesome. So you can start to see some more. We've got much more distinct clustering than what we had before in just R2. And we can actually start to see a breakdown a little bit more of some things that you would expect to see, right? So for example, let's see if I can get this to shift over. It doesn't especially love when I do this. And I'm not particularly skilled in getting it to do what I want. So that's probably the best representation I'm going to get here today. But we can start to see some of those three-dimensional effects, right? And what's kind of interesting to see is you have a couple things that you would sort of expect to see. This isn't exactly the axis that I love, but one of the things you would expect is we've got our 0 friends here. Yeah, I did this wonky, but for the sake of argument, just kind of play along with me. But what you'd expect to see is maybe some people that don't have a lot of friends, so they aren't following anybody back, but they have a significant number of followers, and you think that that would form kind of a distinct cluster, and so you'd expect to see a couple of pieces of data play out like that, and kind of see, again, this linearized trend of influence here. And you can kind of get kind of like maybe, okay, so maybe if I'm down here, I've got a way different kind of influence, or there's something special about this group right here. And you can really start to break down and see what makes these classes distinct. So investment agencies will often do this kind of multivariate analysis, and what they're looking is to try to break through and classify different categories of people. And what they're interested, for example, is like, if I can figure out if, you don't have a lot of friends, but you got a lot of followers, maybe that makes, I can track that back to being extremely low risk, and then I can go ahead and offer you personalized, cheaper investment policies that make me more money. But for our purposes, let's go ahead and use this module to understand where our most significant users are. So we can train a classifier to do this for us. But for the sake of time, we're just going to return our calculated center points when we do a 2 classification model between broadly influential and not broadly influential, and we'll save that, and then we'll use our maps and our distance formula to figure out which those belong to. So interesting observation, but now back to the world of Twitter data and maps and plotting. So we'll go ahead and get our centroid for our 2 cluster. Perfect. And we'll go ahead and record these values because we're going to use them in our program. So now we're going to switch back into our data analysis. And what I did is I went ahead and made these changes in our heat map, because we're basically going to be classifying our broadly influential users and not mapping our not broadly influential users. And so this is just an extension of the heat map class that I've already made. And what I did is I went ahead and recorded some centroid values for some different training data that I had. So we've got 2 centroids here, and I recorded kind of the axes about which these are. So we've got our followers, our friends, and our listed counts, and you can kind of see the difference in the numbers here. So this is X, Y, and Z between our log list is much less influential on the determination, whereas our follower count is much likelier, much more high. Anyways, so I went ahead and recorded these in my program, and then I went ahead and defined what I called an influential user slot, which takes in 2 lists. One is a list of coordinates and a corresponding list of users. And then I go ahead and make an empty list called influential coordinates, or basically what these are is I'm going to iterate through all of my users, and if a user is determined to be influential, I'll go ahead and push his coordinates, his corresponding coordinates, into this list. And like I said, this is exactly what I'm doing, is iterating through my users. And what I'm doing is I'm using a, this was a little wonky how this got wrapped, but a get distance helper down here. I'm passing in my user information, and I'm returning back two distances: the distance to my influential center, the influential centroid, and the distance to the uninfluential centroid. And then what we do is we just check to see which one's closer, right? So if the influential distance is greater or larger than my uninfluential, and actually this is incorrect. If my distance to my influential is less than my uninfluential, less than size, look at you every time, then that means that we're actually an influential user, right? So I want to be closer to this influential centroid than I want to be closer to this uninfluential. So if I'm closer to this, then I'm more influential, and I'll go ahead and add the coordinates to that. And one thing that I made note of here is if the Twitter API is under load, it will not always return you friend and follower information, so I have a little warning right there for that. But once I've iterated through that list of all my users, I've got all my influential coordinates, and so I just go ahead and cheat a little bit and use my prescribed geography slot. This list, which I've labeled as tweets, isn't being used, so all I need to pass in is a list of coordinates, and then I went ahead and changed the redraw number. So now, if I go ahead, and I went ahead and created what I called the final GUI here, just so you can kind of track the progress between the two. But I went ahead and made two heat map widgets. So I've got the heat map widget, which is just the original, and then I've got what I've labeled the influential user widget, which again is just a heat map widget, right? I've just bolted some stuff on there. And I've just hooked them up a little bit differently, and that's the important bit. And you can kind of check that out in my setup signals and slots. Basically, there is in my Twitter controller, I've got an influential, I guess I labeled an important user signal, right? So I hook that important user signal up to my influential slot, whereas for my heat map, all I'm interested in is hooking my geography signal into my geography slot. So got some good reuse in there. But if I go ahead, we can go ahead and run this, hopefully. And we'll switch to our influential user heat map, and we'll go ahead and let this run. Now, since my influential users is so much less than my uninfluential users, this is going to take a little bit to draw. Oh, that's not too bad. So what we can see here is we can actually start to see where some of my influential users are versus my uninfluential users. And I think actually by flipping that sign, I did the opposite of what I intended to, and that I'm much more interested in my the less than. So let's go back to that just real quick here, because one thing that I didn't explain is how I actually do the distance. So let's look at that, and then we'll decide together. So in this get distances helper, one of the first things that we need to do, right, is we get an individual user, and we need to get out the follower count, the friend count, and the listed count. And we actually need to apply the log to that, and NumPy will take in an array, so we'll go ahead and pass our point in as an array. And again, log of 0 is negative infinity, and we don't want that because that'll choke, so we just go ahead and iterate through that. And if it is, we will return the number if it's not equal to negative infinity, and if it's equal to negative infinity, we'll return 0. And then we use the center distance equation out of NumPy, which I've done the fully qualified here. So scipy.spatial.distance.center distance, and we'll pass in our centroids and the actual point that we're interested in. And again, I'm pretty sure I'll have to really think about this, but I think maybe we wanted it like that instead. And if we go ahead and run this final GUI, what we'll see is we've got a significantly smaller number of data points, regardless of what actually comes in. I think this is the actual correct way. So if we let this run for a really long time, right, what we start to see is sort of a heat map of the who's who in the Twitterverse and where they are located at geographically. Geographically is probably a word too. Cool. So we're starting to see some people that are still awake in Japan and in the basic Southeast, and also a couple users in